Gold processing involves several stages, from extraction to refining, to produce pure gold for industrial, jewelry, or investment purposes. The process can vary depending on the type of gold ore, but the general steps are as follows. 1. Mining extraction. Gold is typically extracted from the earth through two primary mining methods. Placer mining, extracting gold from riverbeds, alluvial deposits, and sediments using methods like panning, sluicing, and dredging. Hard rock mining, extracting gold from solid rock formations, which involves drilling, blasting, and crushing the ore. 2. Crushing and grinding. Once extracted, the gold-bearing ore is transported to a processing facility, where it is crushed and ground into fine particles. This increases the surface area for the extraction process. 3. Concentration. To separate gold from other minerals. Concentration methods are used, including gravity separation, using the density difference between gold and other minerals to separate gold particles. Flotation, a chemical process where air bubbles attach to gold particles, allowing them to float and be skimmed off. Cyanidation, leaching, a widely used process where a cyanide solution dissolves gold from the ore. For gold recovery, Merrill-Crowe process, precipitating gold from the cyanide solution, using zinc, carbon and pulp sip, and carbon and leach sil, using activated carbon to absorb gold, which is later stripped from the carbon and recovered. 5. Smelting and refining. The extracted gold is often impure and must be refined. Smelting. The gold is melted at high temperatures, above 164 degrees Celsius, or 1947 degrees Fahrenheit, with fluxes to remove impurities. Electrolytic refining, Wohlwill process. An electric current passes through gold chloride solution, depositing 99.99% pure gold. Aqua regia process, a chemical method that dissolves gold for purification. 6. Final processing and production. Once refined, gold is cast into bars, coins, or used for jewelry, electronics, and other applications. Gold processing is a complex and multi-stage procedure that involves various physical and chemical techniques to extract, refine, and purify gold. Here's a more detailed breakdown of each stage. 1. Mining gold extraction. Gold is found in different geological formations and can be extracted using various methods based on its location and concentration. A placer. Mining, surface mining. Placer gold is found in riverbeds, stream deposits, and alluvial sediments. Extraction methods include gold panning, a traditional method where sediment is placed in a pan and swirled in water, allowing the dense gold particles to settle at the bottom. Sluicing, using a sloped channel with riffles to trap gold while water washes away lighter materials. Dredging, large-scale suction machines extract gold-bearing sediments from B. Hard rock mining, lode mining. Gold deposits trapped in rock formations require extensive mining operations. Open pit mining, large-scale surface mining where rock is blasted and removed in layers. Underground mining, used when gold deposits are deep, requiring tunnels and shafts to extract the ore. Once mined, the raw ore is transported to processing facilities. 2. Processing, crushing, grinding, and concentration. A. Crushing and grinding. The ore is crushed using crushers, and then ground into a fine powder using ball mills or rod mills. Finer particles increase the surface area for chemical extraction. B. Concentration techniques. Gold is typically found alongside other minerals, so it must be separated before further refining. Gravity separation. Uses water and shaking tables to separate gold, which is denser than other minerals. Flotation involves adding chemicals that cause gold to attach to air bubbles, rising to the surface where it is skimmed off. Magnetic separation. Sometimes used if gold is associated with magnetic minerals. 3. Leaching, chemical extraction. Leaching dissolves gold from the ore, using chemical solutions. A. Cyanidation, most common industrial method. The ore is mixed with a cyanide solution, which dissolves gold into a liquid form. Methods include vat leaching. Ore is placed in large tanks where cyanide dissolves the gold. Heap leaching. Crushed ore is piled up and cyanide is sprayed over it, allowing gold to dissolve slowly. Carbon and pulp sip, and carbon and leach sil. Activated carbon is used to absorb the dissolved gold, which is then recovered. B. Alternative methods. Thiosulfate. Leaching, an eco-friendly alternative to cyanide. Chlorination. Uses chlorine gas to dissolve gold. Aqua regia, strong acid mixture, used in laboratory scale extractions. 4. Gold recovery and precipitation. Once the gold is dissolved, it must be extracted from the solution. A Merrill-Crowe process. Zinc powder is added to the gold cyanide solution, causing gold to precipitate out. The solid gold is then filtered, dried and smelted. Activated carbon absorption. Gold-laden carbon is burned to recover the metal. The process allows for repeated use of carbon. 5. Smelting and refining. Raw gold contains impurities like silver, copper, and other metals. A smelting initial refining. The gold is heated in a furnace at over 164 degrees Celsius 1947. Fluxes like borax and silica are added to remove impurities, forming slag that floats on top. The purified gold settles at the bottom and is cast into bars. Electrolytic refining high purity process. Wool process uses electrolysis to refine gold to 99.99% purity. Aqua regia process. A chemical method using nitric and hydrochloric acid to dissolve and selectively recover gold. 6. Final gold products. Once refined, gold is shaped into gold bars and bullion, used for investment and storage. Coins and metals, minted for collectors and currency. Jewelry and ornaments. One of the largest uses of gold. Industrial and technological applications, used in electronics, medical devices, and aerospace. Modern trends in gold processing. Eco-friendly gold extraction. Researchers are developing non-toxic leaching methods like thiosulfate and bioleaching using bacteria to extract gold. Recycling of electronic waste. Gold is recovered from old electronics using advanced chemical techniques. Automation and AI in mining improves efficiency, safety, and recovery rates. Recycling gold into jewelry. Recycling gold for jewelry production is an eco-friendly and cost-effective process that reduces the need for mining while maintaining the quality of the metal. Here's a step-by-step breakdown of how gold is recycled into beautiful jewelry. 1. Collection and sorting of scrap gold. Gold for recycling comes from various sources, including old or broken jewelry rings, necklaces, earrings, bracelets, electronics, gold-plated circuit boards, connectors, and microchips. Industrial and dental gold fillings, crowns, and lab equipment. Gold coins and bullion that are melted for repurposing. Gold items are sorted based on purity carats since different alloys affect the recycling process. 2. Melting and purification, a smelting. The collected gold is melted in a furnace at temperatures above 164 degrees Celsius 1947. Flux materials such as borax and soda ash are added to remove non-metallic impurities. The molten gold is poured into ingots or granules for further processing. Refining purification. To ensure the highest quality, the melted gold undergoes refining methods such as electrolysis. Wool process produces 99.99% pure gold by passing an electric current through a gold chloride solution. Aqua regia process uses nitric and hydrochloric acids to dissolve and recover pure gold. The result is high-purity gold that is ready for jewelry making. 3. Alloying for desired gold carat and color. Pure gold to 4K is too soft for durable jewelry, so it's mixed with other metals to create different carats and colors. 1/8K gold 75% gold, common for fine jewelry, more durable. 1/4K gold, 58.3% gold, stronger and widely used. 1/0K gold 41.7% gold, more affordable and durable. Gold color variations. Yellow gold, mixed with silver and copper to maintain its classic color. White gold mixed with nickel, palladium, or silver, then coated with rhodium for a bright finish. Rose gold, mixed with copper for a reddish hue. Green gold contains more silver for a subtle green tint. For jewelry design and manufacturing. Once the gold is refined and alloyed, it is shaped into jewelry using different techniques. A casting lost wax method. A wax model of the jewelry is created and coated with a ceramic mold. The wax is melted out, leaving a cavity for molten gold to be poured in. After cooling, the ceramic is broken away, revealing the gold jewelry piece. Handcrafting and engraving. Some jewelers hand-carve and engrave gold pieces for custom designs. CNC machines, computer-guided cutting tools, can create precise patterns. Stone setting and polishing. Diamonds, gemstones, or enamel decorations are added. The jewelry is polished and buffed for a smooth, shiny finish. Rhodium plating for white gold enhances the shine and prevents tarnishing. 5. Final quality check and sale. Before being sold, gold jewelry undergoes Purity testing to verify gold carat. Hallmarking stamping for authenticity. Durability and appearance inspection. Recycled gold jewelry is then distributed to jewelers, designers, and retailers for sale. Why recycle gold for jewelry? Sustainable. Reduces environmental damage from mining. Energy efficient, requires less energy than extracting new gold. Cost effective, allows jewelers to create new pieces without high mining costs. Infinite recyclability. Gold can be melted and reused indefinitely without losing quality. Custom gold jewelry design. Custom jewelry design allows for unique, one-of-a-kind gold pieces tailored to personal style, special occasions, or sentimental value. Whether repurposing old gold or starting from scratch, the process combines artistry, craftsmanship, and technology. Here's how it works. 1. Concept and design planning. The process begins with an idea or inspiration. Inspiration sources: nature, cultural symbols, family heirlooms, or personal stories. Jewelry type: rings, pendants, bracelets, earrings, or full sets. Gold type and color: choose yellow, white, rose or green gold and carat. Purity: 1K, 14K, 18K, 24K. Gemstone selection: diamonds, sapphires, rubies, emeralds, or engravings and personalization: names, initials, special dates, or meaningful symbols. A jeweler or designer sketches the idea, or uses 3D design software like CAD computer-aided design to create a digital model. 2. Creating the jewelry. A. Wax modeling and casting lost wax process. A wax replica of the design is 3D printed or hand. The wax model is placed in a mold and covered with a ceramic material. Once hardened, the mold is heated, melting the wax and leaving a cavity. Molten gold is poured in to form the jewelry piece. B. Handcrafting and custom engraving. For artisan-made jewelry, skilled jewelers handcraft gold using hammering, soldering, and engraving techniques to create intricate designs. C. Stone setting. Bezel setting: gold surrounds the gemstone for protection. Prong setting: small claws hold the stone for a delicate look. Setting: tiny diamonds set close together for a sparkling effect. 3. Polishing and finishing. Once the gold piece is cast, it undergoes polishing and buffing to achieve a high shine or matte finish. Rhodium plating for white gold adds durability and brightness. Final quality checks, ensuring purity, structure, and gemstone security. For presentation and delivery, the finished custom gold jewelry is hallmarked, stamped with carat and maker's mark, packaged beautifully for gifting or safekeeping, accompanied by certificates for gemstones and gold purity. Why choose custom gold jewelry? Unique and personal. No one else will have the same piece. Sentimental value: perfect for weddings, anniversaries, or heirlooms. Sustainable: recycle old gold to create something new. High quality craftsmanship, designed with precision and care. Custom jewelry styles and 3D printing in jewelry design. Custom jewelry offers limitless creative possibilities, combining traditional craftsmanship with modern technology like 3D printing. Here's everything you need to know. 1. Popular custom jewelry styles. Depending on personal taste and occasion, here are some unique styles for custom gold jewelry. A. Classic and timeless styles. Solitaire rings, a single gemstone and a simple gold band. Tennis bracelets, a row of diamonds or gemstones in a sleek design. Signet rings engraved with initials, family crests, or symbols. Pearl and gold combinations, elegant and vintage. B. Modern and minimalist styles. Geometric jewelry, sharp lines, abstract shapes, and asymmetry. Stackable rings, thin bands designed to be worn together. Bar necklaces, engraved gold bars with initials, dates, or quotes. Open rings and bangles, delicate unfinished loop designs. C. Vintage and antique styles. Victorian and Art Deco designs. Intricate filigree work with old cut diamonds, engraved gold pieces, patterns, floral motifs, and intricate etching. Cameo and locket necklaces, personalized with portraits or hidden messages. DI nature-inspired and bohemian styles. Floral and leaf motifs, delicate engravings or sculpted gold. Raw gemstone jewelry, unpolished stones in unique settings. Celestial designs, stars, moons, and sun-themed pieces. Personalized and symbolic jewelry. Name or initial jewelry, custom lettered pendants and rings. Birthstone rings and necklaces, featuring personal or family fingerprint jewelry. Gold pieces engraved with actual fingerprints. Soundwave jewelry, gold pendants shaped from a loved one's voice recording. 2. 3D printing in custom jewelry design. 3D printing has revolutionized custom jewelry, allowing for more intricate, precise, and unique designs. How 3D printing is used in jewelry. 1. 3D modeling CAD design. Designers create digital blueprints using software like Rhinoceros Rhino, XBrush, Metrix Gold, or Blender. Every detail is visualized before production, allowing customers to request modifications. 2. 3D wax printing. Lost wax casting. A resin or wax prototype is printed using a 3D printer. The wax model is placed in a ceramic mold, then melted away to create a cavity. Molten gold is poured into the mold, forming the jewelry piece. 3. Direct metal 3D printing. Selective laser melting (SLM). Some advanced 3D printers print directly in gold or metal powders, skipping the wax stage. This technique is used for highly detailed and complex geometric designs. 3. Advantages of 3D printed custom jewelry. Precision and complexity. Fine details, filigree and delicate patterns are possible. Customization. Designs can be easily modified before production. Faster production reduces the time from design to finished piece. Less material waste, sustainable and cost-effective. Stronger, lightweight designs. Hollow structures can be made durable yet lightweight for combining handcrafting with 3D printing. While 3D printing helps with precision and efficiency, artisans still use hand finishing techniques for hand engraving, adding initials, dates, or decorative details. Gemstone setting, carefully securing diamonds and colored stones. Polishing and texturing, creating high gloss, matte, or hammered finishes. 5. Custom jewelry trends for 2025. Mixed metals, combining gold, platinum, and silver in one piece. Eco-friendly jewelry, recycled gold and lab-grown diamonds. Gender-neutral designs, unisex rings, pendants and bracelets. Convertible jewelry, pieces that transform, for example, rings that turn into pendants. Augmented reality AR shopping, virtual try-ons before customization.